made recordings for all of the sample problems that I have 1 through 4, and hopefully that'll help you. LHopital's rule was developed elsewhere, but this is how you actually take with LHopital's rule. So for the first one, what we're going to do is we're going to take the limit as x approaches 0 of sine x over x. We know this one. What's it equal to? We proved it. 1. But I'm going to show you how you can do it with LHopital's rule. First thing is, stick a 0 in. What's the sine of 0 over 0? 0 over 0, right? In IB, you write that. AP as well. So you write, and I want you to write IF, because it's one of those 7 forms. 0 over 0 is the most common. Because it's that way, we can rewrite it as the limit as x approaches 0 of the derivative of sine x, which is what? Cosine x, over the derivative of x, which is 1. And what's the cosine of 0? It's equal to 1. Remember all that work that we did to find that limit equal to 1? And there we just did it in a flash with LHopital's. Let's try that with number 2. Now don't start taking derivatives right away, because if, let's say you had the limit, I'm going to make this up, as x approached 2 of x squared minus 4 over 10x, okay? And if I just stick in a 2 here, what do we get? 4 minus 4 is 0, right? But let's do this with LHopital's rule. 2x over 10, I put in a 2 here, it looks like 4/10. What happened there that I get a totally different answer? Why did I get a totally different answer with this compared to when I did it the LHopital's method? Well, the answer to that is this is not a indeterminate form. This is 0 over 20. Is that an indeterminate form? So you can't use LHopital's for it. So that's something you just got to be aware of when you're doing these. So the first step is always the same. Plug the values in for x, see what happens. 1 minus the cosine of 0 over 0. Is this equal to 0 over 0? Yep. Then write it, IF, indeterminate form. So now that allows you to do the little LHopital. It's like a dance. Do the LHopital. And you take the derivative of 1, which is 0, and it'll be, derivative of cosine is negative sine, right? It's minus cosine, so the derivative of cosine is negative sine, so the negative negatives. And what's the derivative of x? 1. So what's the sine of 0 over 1? 0. And we proved that yesterday too. So everything seems to be working out. Now they do get a little bit more tricky. Sometimes it's hard to plug values in, like this one, negative natural log of 0 all over cosecant of x. So that's a little tough to visualize, but we can do it. We're coming from the right, and natural log does this. So the right of 0 is going to be positive or negative infinity. What do you think? Negative infinity, right? So this one is going to be negative infinity. And then cosecant x looks like this. At, nope, that's not correct. That was secant. Looks like that. As x approaches 0 from the right, cosecant goes up to positive infinity. So go to my list of indeterminate forms and see if infinity over infinity is one of them. Is it? Yep. So this is I dot F. All right, so now all we're going to do then is we're going to say, okay, if that's the way you're going to be, take the derivative, take the limit x approaches 0 from the right. The derivative of natural log of x, did we ever talk about that? 1 over x. You got it. And it is negative. Okay. The derivative of cosecant, oh, you know this one. Cosecant is negative. Cosecant x, cotangent x. Very good. So I'm going to rewrite that over here. The limit as x approaches 0 from the plus side. The negatives will cancel. So you're just going to get 1 over x. Cosecant is 1 over sine, so the sine will end up on the top. Cotangent is cosine over sine, so it'll be cosine x over sine x. There's another sine x here. Somewhere along the line, you can tell me what happens to sine x over x when x goes to 0. I want you to remember that one. Sine x over x is what? 1. So this is 1 times the tangent of x. And what's the tangent of 0? Tangent of 0? Sine over cosine. Sine of 0 is 0 over 1. Yeah, it's just going to be 0. So that's my limit. Not very exciting. But hey, infinity over infinity, giving you 0, that's pretty cool. That's pretty interesting. Let's do one more example. And with the last one, plugging in is no problem. You put in a 0. We just said this was negative infinity, right? Natural log of x is 0, x gets close to 0. Is there a 0 times infinity? Indeterminate form? Well, or negative. It doesn't impact the indeterminate form in this case. So this is an IF. And here's this is why I'm doing this example. Is just this has a little wrinkle to it. I told you there are 2 things you have to do. You got to check the indeterminate form first, and then you got to write it as something over something. And you can't have both things in the numerator. So what's 1 divided by a half? 2, right? So is this the same as x ln x? Is it the same? All right. So then that's going to be equal to the natural log of x going to 0 from the plus, the natural log of x over x to the negative 1. Now we're ready to take the derivatives. What's the derivative of the natural log of x? It is 1 over x. Good. What's the derivative of negative x to the negative, or x to the negative 1? You got it. Perfect. So this is going to be rearranged to be the limit x approaches 0 of negative x squared over x. And if you cancel the x's, you still put a 0 in. Won't this still be 0? So not very exciting. 0 times infinity in this case is 0. But those are 4 examples that you can use to take limits with.